Got two of my favorites for you this morning. Distributive property and order of operations. I said morning because I'm recording this in the morning, but you're watching it at night, so I stand corrected. All right, so the distributive property looks like this when we write it with the variables a, b, and c. And what we're saying here is that multiplying a number by the sum of two numbers is the same as multiplying that number by each of those two numbers. We'll see that done with numbers and with other symbols as well. As far as order of operations, you've probably heard it referred to as PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction. I'm going to say that I don't like that it's not accurate. And I'm going to refer to it instead as GermDOS. This is my special trademarked version of the order of operations. And GermDOS, and I wrote it like that on purpose, because the first thing you do isn't necessarily group or parentheses, but it's all grouping symbols. And grouping symbols includes brackets, braces, parentheses, fraction bars. There can be lots of different grouping symbols. We'll see those as we go about. The E and the R stand for exponents and roots. The M and the D stand for multiplication and division. And the A and the S obviously are addition and subtraction. Okay, so there's your GermDOS. G, E, R, M, D, A, S. So let's perform the indicated multiplication. And so we're going to do 2 times the sum of 3 and W. 3 plus W, we can't really simplify any further. However, we can multiply before we add those two numbers together by doing the distributive property. Okay, 2 times this sum is the same as 2 times each of those numbers. And we can simplify that even a little further. That's 6 plus 2W. Now you can't make that 8W. 6 plus 2W is not 8W. Those are not like terms. They cannot be combined. We'll talk more about like terms later. 5 times x minus 3, that's like 5 times x, and 5 times negative 3. And usually this is how I do distributive property. I usually don't bother with this step too much. I usually just go straight into 5 times x is 5x, 5 times negative 3 is negative 15. Done. Factor each expression. Okay, great. Factoring an expression is like doing the distributive property backwards. And I'm glad we're doing these at the same time so that you see the relationship. Okay. So 9x and 6 are both divisible by, they have a common factor, and their greatest common factor is 3. 9x is divisible by 3, 6 is divisible by 3. So that's why you see this 3 in both of these places here. Okay, and then you just have to do that division. So 9x divided by 3 is 3x, or if you look at it as multiplication, 3 times 3x is 9x. 6 divided by 3 is 2. Or if you look at it as multiplication, 3 times 2 is 6. We're not done yet. We'll write this as 3 times 3x plus 2. That is 9x plus 6 factored. We identified their greatest common factor of these two terms, and we took it out. It's division. So 8w and 10, what are they both divisible by? They're both divisible by 2. So 8w divided by 2 is 4w, and negative 10 divided by 2 is negative 5, and we're done. Which property is illustrated by this following equation? X times the sum of y and z equals x times y plus x times z. That is the distributive property. I showed it to you on the opening slide there using the letters A, B, and C. Here it is with the letters X, Y, and Z. Why might you use the distributive property to simplify 3 times 30 minus 2? You can write down my answer. I'll explain this here in just a second, but multiplying 3 by 30 and 2, then subtracting, is easier than multiplying 3 by 28. Okay. Everybody knows what 3 times 30 is. It's 90. Everybody knows what 3 times 2 is. It's 6. And then 90 minus 6 is 84. As opposed to 3 times 28. Does anybody know what 3 times 28 is, off the top of your head? Well, it happens to be 84. But it's easier to look at it as 3 times 30 is 90. 3 times 2 is 6, and then we'll subtract. Okay, so then we get into some order of operations. Germ DOS, right? So in this expression, there are no grouping symbols, there are no exponents or roots. We do have some multiplication and division, so that's what we need to do first. 5 times 2 is 10. 2 plus 10 minus 1. And then we're down to addition and subtraction. Remember how I wrote the A and the S together? That's because they're basically equivalent operations. So we do them from left to right. 2 plus 10 is 12. And then we'll do this subtract 1. Okay, you'll get a much different answer if you just do these operations from left to right. 2 plus 5 is 7. 7 times 2 is 14. 14 minus 1 is 13. That's not the right answer. Let's do this again. Okay, we do have grouping symbols here. We have parentheses, and I'm going to do both of them at the same time. And the only thing we have left is 7 times 1. 2 plus 5 is 7. 2 minus 1 is 1. 7 times 1 is 7. The identity property of multiplication there at the end. All right. How about this one? We got grouping symbols here, and inside the grouping symbols, we need to decide which one of these operations we do first. We're going to do the exponent first. I'm going to do this exponent too. Well, I could have. It wouldn't have affected anything. We'll finish up these parentheses first. Now that we're done with grouping symbols, we can do exponents. Now that we're done with exponents, we can do multiplication. And we'll add to finish it, 20. Okay, now notice how I get this nice kind of upside down triangle going here. Okay, if you're showing your work properly, that's what it should look like. All right, how about this one? Inside, we're going to do those parentheses first. 6 minus 3 is 3. We still have to do the brackets next. 8 minus 3 is 5. Finally, we can do our subtraction. And again, got that kind of inverted triangle thing going here. All right, germ DOS still applies here, order of operations. So we do have a grouping symbol here. We do have a grouping symbol. The square root symbol groups the 36 plus the 64 together. So that is actually the first thing that we need to do. 36 plus 64 is 100, and the square root of 100 is 10. That is very different than doing the square root of 36 plus the square root of 64. The square root of 36 is 6, and the square root of 64 is 8, and 6 plus 8 is not 10, but this expression is 10. How about the absolute value of 8 minus 12? Again, this is why I said PEMDAS isn't accurate. We're going to go with GERMDAS because G includes all grouping symbols. These absolute value symbols are grouping symbols. You have to do what's inside of them first. So we're going to do 8 minus 12, which is negative 4. Then we'll take the absolute value of negative 4, which is 4. Okay, a mistake I see a lot is that people do 8 plus 12. You know, they take the absolute value of 8 and the absolute value of 12, and then they add them together and they get 20. Nope. Do the subtraction, then do the absolute value. The expression 2 squared plus 2 times 2 minus 2 divided by 2 equals 7. Copy the expression and then insert one pair of parentheses to make the expression equal 11. Well, let me show you, first of all, how that expression does equal 7. If you do the exponent first, then you do the multiplication, then you got to do division, then you do this addition, then you do subtraction, you get 7. So that is what it equals, but we want to insert some parentheses here to make it actually equal 11, and it's kind of a trial and error, guys. I mean, you could put it, you know, anywhere. You could put it around the 2 minus 2 right here and make this a 0. I think putting, you know, multiplying something by 0 is not going to make it bigger though, so that's probably not going to work. We could put parentheses, you know, around the 2 minus 2 divided by 2, you know, around 3 numbers. You know, so it's trial and error. There's really no method to this, but I'm going to try right here. Try and make this a little bit bigger and then multiply it by 2. So this will give me, do the exponent first, I get 4. Then I can do the parentheses, I get 6. Then I can do the multiplication, I get 12. Then the division, I get 1, and, you know, look at that, I get 11. You know, if you can do some of the work in your head first, and it might take you a few tries though, okay? It's not, there's no science to this. It's, you just got to understand how inserting the parentheses means you're going to do the operations in those parentheses first. And then go with it. That's all I got for you today. And we'll see you in class tomorrow to give this problem set a shot. See you then.